Okay guys, today we're starting a new unit and it's about solving quadratics. So the first thing we're going to talk about is how to solve using factoring. So if you remember, a quadratic equation means that the biggest exponent I have is an x squared. So the most general form of a quadratic equation would be f of x equals ax squared plus bx plus c. And a, b, and c can be any numbers that you want. So what we're going to do is we're going to talk about how you can use factoring to help you solve a quadratic really quickly. So the first thing you want to talk about is the zero product property. So a zero product, first let's just remember what product means. Remember, the product is the answer to a multiplication problem. Okay? So if the product of two numbers is zero, then one or more of the numbers is zero. So for example, if I know that I multiplied two numbers together and they equaled zero, then I know that I had at least one of these numbers was zero, right? It could have been like 0 times 10 or 0 times 7 or 0 times, maybe it was just 0 times 0. But either way, at least one of those numbers was 0. The same thing works with polynomials. If you have two or more polynomials that are multiplied together, so like x plus 2 is a polynomial multiplied by x minus 3, multiplied by x plus 1 or something, if those are multiplied together and they equal 0, then at least one of these polynomials that are in parentheses is going to equal 0. Okay? Now, one thing to remember is that this is only true if the product is 0. So you can't say like, oh, well, these two numbers multiply together to give me 3. That means that one of those numbers that I multiplied together has to equal 3. So this only works when your product is equal to 0. Okay? So the nice thing about this is that whenever we're solving quadratics, it means that we're setting them equal to 0. So we're saying, let's take this quadratic equation that I have, and to solve it means set it equal to 0 and tell me which x values, so which of these x values are going to give me 0. Okay? So what we're going to do is we are going to use the method of factoring to solve a quadratic. So there's 4 simple steps to solving a quadratic using factoring. One is you factor it completely, just like you learned last unit. Then you set the equation equal to 0. Then you set each factor equal to 0, and then you solve each factor individually. Okay? So let's take a look at what that might be. We'll look at this example A down here. Now in A, I was nice because I already did the first step for you and I factored it. So the next thing to do is to set it equal to 0, which I actually already did that too. So I did the first 2 steps for you. So then what we do is we set each factor equal to 0. So remember, a factor is something that you multiply together to get something else. That means that x minus 3 is one of our factors. So I'll set that equal to 0. And then x plus 5 is our other factor. So I'll set that equal to 0. Then I'm going to solve each factor individually. So I'm going to come over here to this x minus 3 equals 0, and I'm going to solve it, which means the x by itself. So I'll add 3 to both sides. Then I get x equals 3. So that's one of my answers, x equals 3. And then I'm going to subtract 5 over here to get x equals negative 5. And that's my other answer. So my answers are x equals 3 and x equals negative 5. Okay? And you're going to do the same thing with all of these. Okay, so let's look at B. B looks a little bit different because I have a 3x times x plus 4. Okay? So remember, this 3x out front, that is a factor. So you can't forget to include that when you're setting all the factors equal to 0. So we're already factored. We're already set equal to 0. I'm going to set each of these factors equal to 0 and solve them. So if I have 3x equals 0, to get rid of that 3, I'm just going to divide by 3. 0 divided by 3 is just 0. So one of my answers is x equals 0. With x plus 4 equals 0, I'm going to subtract 4 from both sides so that these 4's cancel out. And I have x equals negative 4. So those are the 2 solutions to my problem. So one thing you can do to make sure you got the right answer is say I know x equals 0 is one of my answers. Okay, I can check that by plugging 0 in for all of my x's, my problem, and make sure I get 0. So 3 times 0 is 0. 0 plus 4 is 4. 0 times 4 is 0, right? Check, I got 0 when I plugged in 0. And a similar thing would happen if I plugged in negative 4. Okay? So let's jump down. I want to do some where you have to work the steps from the beginning. So let's do f together. With f, I have not factored it for you, so we're going to start by factoring. Remember, we have lots of different factoring methods. The first one you always want to check for is factoring out a GCF. So I look at x squared minus 8, and I notice that I could factor an x out. So I have x times x minus 8 equals 0. Then I'm just going to set each factor equal to 0. So x equals 0, x minus 8 equals 0. Now this is nice because x equals 0 is already kind of by itself, so it's already solved. Add 8 over here to get the x alone, and x equals 8 is my other answer. Okay. Notice that I'm mostly getting 2 answers for these. So you're always going to have, you can have 0, 1, or 2 answers. Okay, and we'll talk more about how many answers you can have and why that's the case as we move forward. Okay, let's jump down to h. I know I'm kind of jumping around, but I'm wanting to look at some very specific examples. So with h, before I even factor it, I should actually probably switch the order of the steps. I want to set my equation equal to 0 first. So I want to bring this 12 over to the other side of the equation so that my equation's equal to 0. So I'm going to have x squared minus 4x minus 12 equals 0. Oh, I forgot my x. Sorry, that should be a 4x. Then my next step is to factor completely. So I'm going to factor this, and I notice that I have a trinomial here, so I'm going to do trinomial factoring. So remember, I'm looking for 2 numbers that multiply to negative 12 and add up to negative 4. I notice that I can choose negative 6 and positive 2 as my 2 numbers. Then I'm going to set each of those equal to 0. So x minus 6 equals 0, add 6 to both sides, so x equals 6. And then I'll set x plus 2 equal to 0, subtract 2 from both sides, and x equals negative 2, and that's my other answer. Okay. So sometimes the trickiest part of this is really just factoring it. Okay. So why don't we do one that maybe is a little bit trickier factoring? Let's do k. So remember, whenever we're factoring, the first thing we want to do is look for a greatest common factor. And in k, we have 3x squared plus 15x plus 18, and the GCF here is 3. So I'm going to factor the GCF of 3 out, left with x squared plus 5x plus 6. Then I can do the shortcut trinomial factoring because my a is 1, which means I can just look for 2 numbers that multiply to 6 and add to 5. And those numbers can be 2 and 3. So I have x plus 2 and x plus 3. Oops, I forgot to put my equals 0. Then I'm going to set each factor equal to 0. So 3 equals 0. Whoops. X plus 2 equals 0. And x plus 3 equals 0. Okay, let's look at this first one. 3 equals 0. Well, 3 doesn't equal 0. There's no way I can make 3 equal to 0. So this is not going to give us a factor. It's not going to give us a solution. Okay, that 3 out front is going to affect the graph and some other things, but it's not going to affect the solutions. Then I'll solve for x here. X equals negative 2. And then I will solve for x here. X equals negative 3. So my 2 answers to that one are x equals negative 2 and x equals negative 3. So as you work through these, just remember to keep track of what your factors are. Make sure you're setting them equal to 0 and that you're being really, really careful with keeping track of your signs, positives and negatives. Okay. Let's do one more thing. We're going to talk about some story problems. One of the coolest things about quadratics is that they are hugely important in the real world. We use quadratic equations and models to model and represent tons of different situations. So we're going to look at some story problems. So here I have some steps and tips for solving story problems. So first of all, you want to make sure you read the story, write an equation, solve for the variable, and then always check your answer at the end, okay? And then here's some more tips. Identify the things that you know. Try to figure out what you're trying to figure out. Draw a picture. Drawing a picture can be so helpful to help you visualize the situation. Carefully define your variables. So if you're going to use an x, make sure you write, x equals the number of dollars or the number of inches. Translate the words into symbols. That's kind of like writing the equation. Make sure you're using good units. And then at the end, make sure your answer actually makes sense. Okay? And then here's some hints that are also just good things to remember. Remember sum. If I say I'm having a sum, I'm adding difference is subtracting, product is multiplying, and quotient is dividing. And then here's just some other formulas you might have forgotten, like area, perimeter, and then what a dimension is. So let's jump into a story problem. So an envelope is 3 inches longer than it is wide. The area is 180 inches. What are the dimensions of the envelope? Okay, so what I know so far is that I've got an envelope. So let's draw a picture of an envelope. So it's going to be some sort of rectangle. You're going to learn that I'm not a very good artist, but that's okay. So it's 3 inches longer than it is wide. And then the whole area is 180 inches squared, or square inches. Okay. Now I need a way to represent the length and the width. I don't know what the length and the width are, but I'm going to call this W, which is the width, or the shorter side. And then I know that the length, or it's 3 inches longer than it is wide. Oh, yeah, it's 3 inches longer than it is wide. Okay. So this bottom part is going to be whatever the height of the width, or the width of my rectangle is, plus 3. So it's got 3 extra inches than the other side. Okay. So now I'm going to use my diagram to write an equation for the area of the picture. So I know to find the area of a rectangle, I do length times width. So I would do my W plus 3, which is my length, and then multiply it by my width, which is W. And that would equal the area. And in this case, I actually know the area. The area is 180. Okay. Now one thing I want to do, since I introduced a variable up here, I want to make sure that I say what the W is. So the W is the width, and I want to say that it's in inches, because I want to know that when I get my answer at the end, it's not going to be like in feet or in centimeters or something. Okay. Now I need to solve the equation, okay? So I've got W plus 3 times W. So first what I'm going to do is I'm going to multiply the left side of the equation together to get W squared plus 3W equals 180. So all I did was distribute the W into both of the numbers in the first set of parentheses. Then I'm going to try to solve by factoring, because that's the only way I know how to solve. So I'm going to subtract the 180 over to set my equation equal to 0. And now I get a factor. So luckily I get to do trinomial factoring. I get to do the shortcut because there's no number in front of the W. So I'm just looking for two numbers that multiply to negative 180 and add up to 3. So one thing I know is that, I'm going to do this part in red so that I know it's kind of work on this side. 12 times 15 is equal to 180. And I know that if I need to get negative 180, then I need to have one of those numbers be negative. So I'm going to make the 12 negative. So negative 12 times 15 is equal to negative 180. And negative 12 plus 15 is equal to 3. So my two numbers I'm going to use are negative 12 and positive 15. Okay, so I'm in factored form now. And now I'm going to come over here and I'm going to solve each of my factors. So W minus 12 equals 0, and then W plus 15 equals 0. I'll solve both of these. So W equals 12 minus 15 from both sides here. So W equals negative 15. Okay, so 12 and negative 15 are my two answers. Let's talk about a couple of things. First of all, I want to know what the units are for this. And I know that I was doing the width in inches. So this is like 12 inches or negative 15 inches. And then I want to remember this W is supposed to represent the width. So the width could be 12 inches. That works. But the width could not be negative 15 inches. So even though negative 15 is an answer to the equation I wrote, it's not an answer to the story problem I'm dealing with. That's why you want to make sure your answer makes sense. Because even though the math might say, hey, negative 15 is your answer, this is when you have to use your human brain and say, yeah, but negative 15 can't be the width of an envelope. Okay? So I know the width is 12 then, so my final answer is that the width is 12, which means that the length is 3 inches more, so it's 15. So my envelope is 12 inches by 15 inches, and that's going to be my final answer.